much, Thomas, for that wonderful intro. So thank you all for showing up. We're going to talk about Sidecar-Less sidecars for your application in Service Mesh. So let me make sure clicker works. All right. About 10 years ago, I decided to build my house, kind of fulfill the American dream, right? So this is actually the house under the construction of my house. So I was always curious, what are the roles involved in building a house like this? Of course, you know, I'm building a house on a budget, right? So I can't afford to hire every single individual for my own. So these roles are the people who are actually building my house. But they are also building a bunch of other houses in the area, right? So imagine them maybe have like 1% or 5% of their time contribute to my house where they were building my house. My name is Lin Sun. I'm the head of open source at a small company called Solo.io. I live in Cary, North Carolina, which is where that house is located. I'm a very long time Istio contributor, being one of the founding members in the Istio organization. I worked at IBM for 19 years. Right before I leave IBM on the last day, I went to the corporate directory and took a screenshot of how many patents I contribute to IBM. So that's 207. I wrote 2 books about Istio, both with O'Reilly. The first one was about Istio with Sidecar, and the most recent one is the Istio without Sidecar, which is what Thomas is talking about, Istio Ambient. I'm also very, very involved with CNCF. For those of you, how many of you know what CNCF is? All right, I do expect many of you. So I'm one of the newly elected TOC member. I'm also a CNCF ambassador. The problem we're trying to talk about today is as our application move to the cloud, as they become distributed, how do we ensure they can connect, secure, and observe successfully? So if you go back to the problem of me trying to build my house, right? Imagine these people, they don't work for me 100% of their time. So in order to make sure they can connect, secure, and observe their communication successfully, they would have to drag a sidecar. Unless we can change these people, which changing people normally is harder, or changing applications harder to drag the sidecar. So now you can envision my house would be packed with a bunch of sidecars as these workers come to help building the house. Now, I'm going to ask you, how many of you know what Service Mesh is? All right, perfect. How many of you are using Istio today? All right, a few of you. How many of you want to look into Service Mesh, but actually walked away from Service Mesh because of sidecars, because of the complexity of sidecar? Awesome, thanks for that hands, appreciate it. So since you all know what Service Mesh is, I'm not going to introduce in great length. So basically, it's a programmable framework that allows you to solve the problem I was describing, right? Connect, secure, and observe microservices. Service Mesh has a couple of evolutions. This is the CNCF landscape. There are 2 graduated projects related to Service Mesh right now, Istio and Linkerd. And interestingly, most of the Service Mesh projects using Envoy as the sidecar proxy, except the Linkerd. When we started launch Istio in 2017, it was using the sidecar approach, right? So the thinking behind that is with the sidecar, you don't need to change or modify anything in your application, and then you can do connect, secure, and observe your microservices in a declarative way. At the same time, the Linkerd project launched their Service Mesh, which was called Conduit, and they were using an interesting notion of, without using sidecar, using a no proxy. But soon they realized the sidecar architecture is more mature, more secure. It's have like the least granularity of security. It has solve a lot of concerns they've seen from their user. So they actually switched to the sidecar model. We have a lot of very, very happy sidecar users out there from Istio. So this is a screenshot from Istio.io. You can see AutoTrader, Airbnb, Splunk. They're very happy with Sidecar today. So this is not to say, Sidecar is not great. We do have very happy users out there, and we do intend to continue to support Sidecar as a valid service mesh architecture for a very, very long time. However, there are certain challenges with Sidecar, and we do realize a lot of users was holding up their service mesh adoption because of the challenging with Sidecar. So let me walk through you all a little bit on the challenging of the Sidecar. So the first challenging is transparency. So unfortunately, it requires the injection of the sidecar, right? Where I showed the picture of my house with the sidecars parked in front of my driveway, right? So you would have to, the moment you drag the sidecar with you, you kind of have to restart your application. You have to allocate resources for that sidecar in terms of CPU and memory. You have to handle any startup and shutdown sequence between your application container and your sidecar proxy, and your application might have its own sidecar, regardless the sidecar the service mesh provides. So you have to handle any potential conflicts related to that. And the upgrade always require restarting of your application. And if you're running Kubernetes jobs, unfortunately, when your job finishes, the sidecar doesn't finish. So there are certain issues with supporting Kubernetes jobs, and which is why a lot of users come to service mesh. They find out, oh my God, my application doesn't work. This is not as transparent as I'd have hoped for. The other challenge with sidecar is incremental adoption, right? The moment you drag the sidecar, regardless whether you need a function such as just connect, or maybe just secure, maybe you just come to service mesh, you need mutual TLS, or maybe you just need observability, you have to drag the entire sidecar with you. So it's all or nothing injection of the sidecar. So there's no layer architecture associated with sidecar at the moment. The other challenge with the sidecar is security. If you look at the Envoy CVE, most of the Envoy CVE, I have to say 2/3 of the Envoy CVE related to layer 7 processing. However, you may not need layer 7 processing, but the fact that you are dragging the sidecar with you as part of your application, that means you can potentially expose to those layer 7 processing CVEs. And along with that, there's also over-provision of resources. We've heard of a user complaining about the sidecar using a lot of RAMs. The sidecar requires excessive resource requirements. The default resource limits, they didn't quite like what we config for the user. So there's a bunch of challenges related to that in the sidecar. So in 2021, there's another service mesh evolution out there from the Cilium project. And they started with a magic button of eBPF. So they went back to can we run proxy per node to handle both layer 4 and layer 7 processing. So this is a diagram from one of the blogs from iSurveillance talk about can eBPF perform layer 7 function, right? So can we use eBPF to do the magic of layer 7 processing? I think the industry have come to the conclusion across different projects. eBPF is great, it's magic in a sense a lot of people don't really understand. But there are a lot of layer 7 tasks that's not very appropriate for eBPF tasks. For instance, on the resilience side, right, timeout and retry, it takes time. So the kernel couldn't verify when the program is going to finish. It's going to be very, very hard to do in eBPF. some of the layer 7 routing have very complex request manipulation. The load balancer algorithm, it could be very complex, and those are very, very hard to do in the kernel. So using resiliency as a case study, like for instance, in service mesh typically support retries, right? You want to schedule a retry with the exponential backoff, or you want to support circuit breaking, right? Stop sending requests if upstream has more than X active requests, right? So these things are very, very hard to do in eBPF. Now, I want to start talk about Istio Ambient after I set the background on where things are, right? So we launched Istio Ambient, what Thomas was talking about, in September 7, 2022. And we're very excited because this is a new data plane mode without sidecar for service mesh. And Matt Klein, who is a founder of Envoy proxy, and he actually chimed in on Twitter, said this is the right approach for service mesh. Sidecar has unfortunately been always unfortunate implementation detail and brings unnecessary complexity. So we introduced ambient service mesh in that year, and for the focus of simplified operation, right? You no longer need to restart your application because there's no sidecar associated with it. We do, for the focus of reduce the cost, right? Because you don't need to provision that sidecar, and also we scale it along with your application. And improve performance is our third goal, because we do believe it would improve performance, but it wasn't the major goal. Because with Sidecar, we find out the latency was under 1 millisecond, which is very, very low latency already. So let me walk through you the Istio Ambient architecture. So how many of you are familiar with node agent today in Kubernetes? You're probably using some type of node agent already, right? It's kind of an agent running on the node. It's per node, right? So in Istio Ambient, we introduce a component which is very similar as a node agent. We call it a zero trust tunnel. So effectively, that component have all the incoming and outgoing traffic go through that component. It's co-located on the node as your application container, and it assigns identity for your application. It upgrades the connection to mutual TLS, and then you can see the encrypted traffic is sending through the source Ztunnel to the destination Ztunnel without any need of sidecars in this case. So that's why we call it a secure overlay layer in Istio Ambient. How many of you know what gateway is? Raise your hand. All right, most everybody, right? So gateway is a very familiar concept. In Istio Ambient, we also introduced the gateway concept as a Waypoint proxy. So the way to think about Waypoint proxy is the component that's built on top of Envoy proxy. It handles layer 7 processing. It's kind of like a gateway into your application, your destination application. So you can have different scope for your Waypoint proxy. You can have based on service account, you can based on namespace, or you can have it based on what multiple namespace. It depends on whichever tenant scope you feel comfortable. So in this example, you can see when application A send a request to application B, it's going to be captured by the co-located zero trust tunnel, which is the node proxy we talk about. And then, because the application B has its own Waypoint proxy, by the way, Waypoint proxy is optional. It's only when you need layer 7 processing. That's when you deploy your Waypoint proxy, and then the traffic is going to forward to the Waypoint proxy. That's all the layer 7 processing we talk about, circuit breaking, retry, timeout, traffic shifting based on maybe headers and weight. So that's the role of the Waypoint proxy. And then once the Waypoint proxy for application B decides whichever endpoint of application B is going to go, and then forward the traffic to the application B, which is going to be captured by the co-located zero trust tunnel and decrypt the traffic to plain text and forward to the application B. So in a nutshell, the ambient architecture is really slicing the layers of the mesh into two. So we talk about the node proxy. It's effectively the secure overlay layer. It provides traffic management at TCP layer. It provides mutual TLS security, simple authorization policy. You can do policy enforcement and TCP layer observability. It also provides the layer 7 processing layer by the Waypoint, which you really can think about it as a gateway if you are familiar with the gateway concept. So this layer 7 processing does traffic management on the HTTP layer. It does rich authorization policy where you can apply authorization policy based on headers, based on response code. It provides HTTP metrics for observabilities and logging and distributed tracing. All right. Okay, now I want to talk about why we decided to go with the two-layer architecture in Ambient. Now, if you think about Envoy, is Envoy really designed for multi-tenancy, right? So we thought about having Envoy per node, but we realized Envoy is not designed for multi-tenancy. The reason is if one of your tenant has an outage, right, it's going to impact the other tenant. And most of the Envoy complexity lies in layer 7 processing. So layer 7 uncontrolled layer 7 config and processing can really be a disaster for multi-tenancy, for cost attrition problem. There's just a bunch of things we decided it's a huge issue. You don't want one tenant's Envoy bring down another tenant's layer 7 processing and break the traffic. And interestingly enough, Matt Klein, who is the founder of Envoy, also agrees with that sentiment. Envoy was not designed to be multi-tenancy for layer 7 processing, and the complexity is not worth the cost. So we're putting a lot of thoughts on design ambient for scale. So if you look at pre-programmed Envoy proxy, if you happen to use Sidecar today, you can see that essentially the Istio control plane sends generate Envoy configuration and then send very large XDS configuration to the Envoy proxy. So that's how Sidecar works today. And then Envoy executes the configuration. The reality is Envoy configuration are not meant for people. It's meant for machine. How many of you feel you have a good understanding of Envoy configuration? Raise your hand. All right, and not surprisingly, yeah, it's very complex. This is a diagram people showed how complex Envoy configuration is, even just with like a couple of services in the service mesh. So we started back to the drawing board on what do we do, right, in this case? How do we simplify the configuration, especially on the secure overlay layer? So we started to ask ourselves, is Envoy the right proxy for Zero Trust Tunnel? What if we just send what's absolutely necessary configuration from the control plane down to the data plane? Wouldn't that help you save a lot of cost on the memory of the proxy and also the bandwidth cost? So we started to kind of list, what are the information would be necessary for the Zero Trust Tunnel, that node proxy we talk about. So we started to think, it's going to need a bunch of these information for the co-located workloads, right? It needs the name. It needs to understand, does it speak Edgebone, which is the HTTP overlay layer that the Zero Trust Tunnel upgrade the connection to so that it can be encrypted? Does it have Waypoint proxy? Does it have any layer for authorization policy? And then we decided just understanding the co-located workloads is not enough, right? It needs to understand what's going on in the entire mesh. So in addition to that, the workloads can be Kubernetes services. It can be out of mesh, and it can also be like workloads running on the VM. So this is the Zero Trust Tunnel configuration we end up with. You can see it's very, very simple. And the moment user add that workload into the ambient, we're going to mark the protocol to be edgeborn. And then we're going to, if they attach any authorization policy, we're going to attach the authorization policy to the workload. So these configuration, how many of you feel like you can understand it without like reading documentation? Yeah? Okay, awesome. That's, we accomplished something, right? It's much simplified workload XDS configuration. You agree with me, it's very simple to read and debug, right? It's much less resource for the Istio control plane to generate the configuration, and also it reduces the network cost between the Zero Trust tunnel and the Istio control plane. Now, the next question we start to think is, what's the right implementation for the proxy that handles the layer 4 layer? We started with Golang, and we started also with C++ as prototype, and we decided with Rust. The reason is Rust was very high performance and very low utilization, and it has very successful proxy out there. Cloudflare guys had a very successful proxy based on Rust. And we also did some study on this. John Howard, who is the main contributor to the Istio project, he ran a study with 150K pods and set up with Istio Ambient. And the Zero Trust tunnel, in that scale, it's just 500 meg of RAM. So that's very, very impressive to the scale of the Zero Trust tunnel with the Rust implementation we have. Now, I want to spend a minute to talk about Waypoint proxy after we discuss about Zero Trust tunnel. So Waypoint proxy is based on your preferred tenant scope. So you can, based on service account, namespace, or multiple namespaces, whichever tenant scope you prefer. And to deploy your own Waypoint proxy is also very simple. You can use our Istio CLI, and then you can specify the scope you wanted. Whether it's namespace or service account. So in this case, we're creating a Waypoint proxy based on service account. So when we started to implement Waypoint, we also want to design Waypoint proxy for scale. So we put a lot of thoughts into that. So we started to think about, okay, layer 7 processing, Envoy proxy is the best, so we want to reuse Envoy for that. But how can we simplify Envoy configuration? Because we talk about how complex it can be. So when we started looking into this, we started to think through, right, today in the sidecar world, the service producer and service consumer essentially trim down Envoy configuration by using export2 to declare, what services I'm exporting to outside of my namespace, and also the sidecar resources to define what are the services I'm importing into my namespace. So that's not very convenient, but unfortunately, every single user out there using Istio in production, they probably config this to make sure their proxy configuration are not overly complex. So this diagram really shows the power of these configurations. So I'm starting on the service producer side. You can see by applying the export2 annotation, I'm effectively trim the sidecar proxy configuration to trim down these containers from namespace 2. So I don't need to be aware of these application or services. And then on the service producer side, by applying the sidecar configuration, I'm effectively trimmed down a bunch of more sidecar configurations, right? And if I apply this to namespace 2, now I'm effectively trim more configurations. That's how essentially a user tells us how they want to trim down their sidecar configuration. So it doesn't scale as they added more application into the mesh, in case those applications are not relevant to their application. Now, we look into the simplification for the Waypoint, and we want to achieve something similar for the Waypoint, right? So do we require users to config sidecar and export2? If we don't have to, we choose not to, right? Why would we? So we come to the conclusion, the Waypoint proxy should only focus on the destination side for the destination application. In that case, if there are 100 services running in the mesh, they only need to care about the destination services they care about, and they don't need to have additional configuration for Sidecar export too. So really simplify the user's configuration and in turn simplify the Waypoint proxy configuration. So this is a study we did on each namespace scale to 25 deployments with 10 pods in each, and each Waypoint proxy scale up to 2 pods. As you can see with Sidecar, the configuration is it's about 100 times bigger than the Waypoint proxy. It's a little bit over, it's like a 125 over from the Sidecar to Waypoint proxies just by focus on destination only Waypoint proxy. What about policy enforcement? So if you're using Service Mesh today, you probably realize some of the policy enforcement, some are enforced on the client side, some are enforced on the server side. This is very, very confusing, unfortunately, to our user. So with this shift to focus on destination-based Waypoint, all the policy enforced on the destination side. Let me show you how this would make a difference. Envision you have a mixed environment where your client may be inside of the mesh or your client may be outside of the mesh, right? So if you are relying on client-side enforced policy, if your client is outside of the mesh, it wouldn't work very well. It wouldn't work at all, I should say. But if you're using Ambient with Waypoint, because the policy are always enforced on the destination side, so it would actually be enforced even if your client is outside of mesh. So let's talk about user experience, because I want to get to you guys a demo just to show how simple it is, right? In order for you to add your application to Istio Ambient, the only thing you need to do is label your namespace with data plane mode Ambient. A lot of application requirements are eliminated if you're familiar with Sidecars. Kubernetes jobs we talked about earlier are supported in Ambient. The Sidecar was using like an application ID, certain capabilities, and certain ports are used by the Sidecar proxy. So all these are eliminated the requirement with Ambient. So it's really simplify application onboarding and surprises as you onboarding your application. Now I want to spend a minute to review the security in this model, right? So by separating the application and the data plane from each other, right? If your application gets compromised, who think you have, you write the perfect application who would never get compromised, right? Nobody, right? So if your application ever gets compromised, you don't necessarily, the hacker doesn't necessarily get to compromise the Zero Trust Tunnel or the Waypoint proxy, right? So that's a win. Now, we talked about early on, most of the CVE relies in Envoy proxy relies in the layer 7 processing. So if you need just the secure overlay layer function of the mesh, then you are not exposed to any of those CVEs because your Zero Trust Tunnel handles very, very minimum function, right? And the third point I want to make is the Waypoint proxy is per tenant, right? So if it's one of the tenant had an issue, it doesn't necessarily impact any of the other tenants from a security perspective unless the hacker knows how to get into the Waypoint proxy and use that same way to get into multiple waypoints together. So we do think Ambient is more secure than Sidecar in this incremental adoption scenarios. Now I want to spend a minute to talk about state of Ambient, right? I talk about the Ambient architecture, how we design Ambient for scale. So we launched Ambient in 2022, and Ambient was alpha in 2023. In KubeCon 2024, we just announced Ambient beta, and we are working very, very hard on Ambient Istio 122, which is the Ambient reaching beta, when we recommend users to run Ambient in production with caution. And we do expect Ambient would go GA sometime later this year. Don't quote me on the dates or everything, but I'm hopefully 123. One of the hurdles we have in the community is to support multiple versions, multiple different container CNI, container network interfaces. For example, Cilium, for example, Calico, for example, any of the cloud CNI, right? So that has been a long thing we worked in the community. The reason is we want to make sure your policies from the CNI can continue to be enforced and not impacted when you are running Istio Ambient Service Mesh with Zero Trust Tunnel. So we just resolved that hurdle a couple of months ago in the community. That's why we started to, mature Ambient for production ready for beta. We've done a lot of cost analysis study because cost is a big thing, right? I realize a lot of users look at service mesh and they walk away from it. It's because of the cost and the complexity, right? So the baseline is your application not in service mesh. So your application deploy in Kubernetes. The Sidecar is with Sidecar. The Ambient is the one with Zero Trust Tunnel. And the last one is the Ambient with Waypoint with layer 7 processing. So what's really, really interesting here, based on our study in GKE, Google Cloud with 150 also applications, we realized that when we add sidecars to these applications, we had to scale the number of nodes from 12 to 15, so that results about 30%, 40% increase of the cost per month. However, when we just added the application to Ambient, it didn't require any node of scale, so the cost remains the same. The CPU and memory increased slightly, but the increase didn't trigger any of the scale out of the nodes. And when we started to add layer 7 processing Waypoint proxy to the study, we do find out the increase a little bit more on the cost, but still much better than the sidecars. We've also done CPU and memory study. In this case, you can see no mesh, sidecar, and Ambient layer 4 and Ambient layer 4 and layer 7. You can see as far as CPU and memory comparison, Ambient is definitely a clear win for all the stacked CPU added together and the RAM added together, particularly for the RAM. So this is the same study of 150 service across 12 namespaces. You can see on the memory side, Ambient doesn't really increase much memories at all. Now let's get to a demo. All right, so for the interest of time, I was going to show you live, but for the interest of the time, I'm going to pull out the recording. The reason is my environment somehow didn't quite work. So can you guys see the demo in the back? Is the font okay? All right, perfect. So on my cluster, I'm installing Istio. And I'm also start up K9S, so I can visualize what's going on with my cluster from a pod and services perspective. So you can see Istio control plane, Istio D was just installed. I have Istio CNI also installed, which is installed as daemon set. And you can see it's per node, and also Zero Trust Tunnel was just installed. Now I'm install a bunch of add-ons to Istio. Prometheus, Grafana, and now I'm install the Kubernetes Gateway API. So you can see, how many of you are familiar with Kubernetes Gateway API? All right, a couple of you, great. Now I'm deploying my sample application, sleep, not sleep. Actually, I deployed the sample application before I recording, so I'm just deploying my client for the application. Now I'm also setting up the booking for gateway to make sure I can access the booking flow application from outside of the cluster. So let's review the booking flow gateway YAML together. So if you're familiar with the gateway API, you can specify like the listener, you can specify the ports, and you can bind the HTTP route to the gateway resource. In this case, the HTTP route is binding to the booking flow gateway. So as you can see, I have all my application trying to reach running. There's no sidecar or anything, right? I'm not even having added anything to the mesh yet. You know, the product page is still coming up running. I have booking flow gateway, which is also come up running. So that's the one I config the HTTP route on the gateway to make sure I can access the booking flow product page from outside of the cluster. So what I'm doing now, just pause a second. So I'm waiting for the gateway of booking flow to reach running to get status programmed. I'm also config the gateway host and the service account, just making sure, you know, we can access the booking flow through the gateway. So I have kind of everything set up. So now I'm going to access the product page, which is the booking flow landing page through the gateway host. As you can see, you know, I have a couple of clients, sleep, not sleep. So these clients are just curl application, just making sure I can curl the bookstore application. So now I'm going to generate some node. By the way, one thing I forgot to highlight is I actually, now that my application is running, I'm actually labeled my namespace to Ambient, right? It runs so fast, I didn't really realize, but I want to highlight it, right? So after I make sure my application works, I label the namespace, make sure, you know, I can add my namespace to Ambient, so that effectively add every single path in that namespace, which is default, into the Ambient service mesh. And as you can see, you know, my application continue running as it's, after it's added to the Ambient. Now I'm generating some node just to making sure I can continue show you guys the benefit of adding the application to Ambient. So I'm starting Kayali and the Prometheus dashboard. So from Kubernetes K9S perspective, you can see I'm still running 1/1, so there's no sidecar involved. So the only thing I did is ask Istio Ambient to add these applications to be part of Ambient, but there's no restart or anything of these applications. So you can see it's 0 restart, right? So go to the Kayali dashboard. Now I'm hoping to visualize what's going on. So I'm going to select the default namespace, and I'm going to select traffic animation. So hopefully show me the security a little bit too on what's going on, right? So as you can see, I actually see the graph, right? How the booking flow application works, right? It composes a couple of microservices. And here you can see I'm getting TCP data already, right? So if I fast forward here, back forward here a little bit, as I click on these connections right here, right? I'm actually visualized into what's going on. You can see it was mutual TLS between the product page to review with the SPIFFE ID. I have TCP traffic. Right? So I have TCP traffic on the bytes, on send and receive. So all that data is available for me just by the fact of I'm adding my application to Ambient. All right, on the Prometheus side, how many of you are a fan of using Prometheus in your work? All right, I imagine a lot of you. Thank you. By just adding my booking flow to Istio Ambient, I'm getting TCP metrics. There are a couple of TCP metrics provided. So connection open total, connection close, and also the bytes. These are the ones that's provided by Istio automatically. Now I'm going to show you an example of layer 7 processing just to control traffic. So notice layer 7 processing is optional, right? So I only need it when I need to control traffic. In this case, I'm applying a Waypoint proxy for the review services. And I'm also deploy booking for reviews and also HTTP route to config. 90% of traffic goes to version 1 and 10% of traffic goes to version 2. So I'm going to show you quickly what these two YAML file looks like. You can see these are just different services have their version. And most importantly, the weight here is the most important thing, that I want to distribute the weight between review version 1 and review version 2. Once again, I'm not using any sidecars, no restart of my application, and the booking for review Waypoint is coming up, reached running already. And you can also see from my output, right, there's very little version 1, very little version 2 there. It's mostly version 1. So let's go back to the Kayali dashboard, which is continue visualize what's going on within the mesh for us. Now, in this case, we'll drill into what's going on with review version 1. Ta-da, we're getting TCP requests per second, right? These are the information from the Waypoint proxy on the HTTP layer that we were not able to see with just the Zero Trust tunnel. We can also enable like additional information such as response time, traffic rate, and all that. So all these should be available as you add a Waypoint proxy to the mesh. And again, this is without needing for you to redeploy your application or make any code change to your application. So you get requests per second, you continue to get the TCP information. Back to the permissions side, now we also have HTTP metrics now. So for instance, you can get Istio request total, right? Which shows you the response code, which shows you the connection is mutual TLS. It shows you like the source and target, all that information is available. Again, this is without any restart or any sidecars, just by using Istio Ambient that you can gain layer 4 metrics, layer 4 mutual TLS, and by optionally deploy Waypoint proxy, you can do traffic management, traffic shifting, traffic resilience, or reach layer 7 authorization policy, all that with Istio Ambient Service Mesh. All right, so hope you enjoyed that demo to really showcase how easy it is to use Istio Ambient. You might be wondering, what about sidecars, right? Sidecars continue to be here to stay. For many of our users who are very, very happy with sidecars, we will continue to support them as long as user tells us they want to stay with sidecar. We will continue to support them as a community. If you ever have source-side specific configuration, that's a great fit for sidecar because with Ambient, we're shifting a lot of logic on the server side. So if you need to do like source-based routing configuration, sidecar may be a better fit. And if your destination side specific configuration is very granular, more granular than service account, for instance, you want to deploy a Vasa module maybe only for one of your workload, but not for other workload in that same service account. So that's when Sidecar will continue to be useful because it provides more granularity than Istio Ambient and Waypoint proxy. Now, to wrap this up, Ambient is the new data plane we introduced in Istio. Ztunnel is very lightweight, no proxy with very, very little overhead on CPU and memory. Waypoint is optional. You only need it when you need a layer 7 processing, and you can select which one to use, which service, like we needed for review, so we deploy for review, but didn't deploy it for the rating services. Ztunnel and Waypoint are designed to scale with very minimum configuration. Now, I want to go back to my house, right? It's all about this house. So this is actually the finished house. We've been living there for the past 8 years, really enjoy the house. And wouldn't it be wonderful, like these workers come to my house, they didn't have to worry about sidecar or park the sidecar in front of my driveway. I would encourage you, if you are interested in the benefit Service Mesh can bring, try Istio Ambient. You can reach out, scan that QR code, read my book, engage with us in the Istio community. This is a lab we provide with a free environment if it's interested to you. And I want to thank everybody for being here. And if we have time for questions, Thomas?
Yeah, I think we have about 5 minutes for questions. Does anyone have any in the audience?
Do you support any other platforms like AWS ECS?
Yeah, that's
Can you repeat the question?
Okay, so I think the question is, does Istio Ambient support any other platform like AWS, ECS? Okay, so that's a great question. I know we support Kubernetes distro, any Kubernetes compliant distro. Now, is ECS based on Kubernetes? Oh, okay, so yeah, so that we haven't looked into, but we do support EKS, we do support Azure, we do support GKE. So yeah, not at the moment yet. Great question, though. Any other questions?
Right over here in the front. Just ask questions.
Okay.
Yeah, my question is, in the sidecar world, we used to apply deployment-specific resources in sidecar resources. Like when we know that deployment taking like a lot of signature verification, decoding, we just add more resources to it. How we manage specific resources in Ambient?
Yeah, that's a great question. So I think the question is, in the sidecar world, correct me if I'm wrong, as a user, you tend to manage like the resources with sidecars to try to deploy and provision more resources with sidecar as needed. And the question is, how do we manage these resources with Ambient, with Waypoint proxy, and Zero Trust Tunnel, right? Okay, so that's a great question. So for Zero Trust Tunnel, because the function its performance is very, very minimum, so we've done a lot of study, and we do envision you will continue to keep the resources very low. So if your question is more about Waypoint proxy, I would imagine, right? So the good thing about Waypoint proxy is, first of all, you don't need to trim the configurations because it was designed to have minimum configurations, which just handle the destination side of your application. Second of all, Waypoint proxy scales independently out of your application, so you do have a lot more control. So if you think about the sidecar world, right, if you have 10 pods for your application, you literally have 10 sidecars, right? Because each of the pods have its own sidecar. In the case of Waypoint proxy, you will be able to scale up by number of replica, or maybe by CPU and memory on your own as a different cycle outside of your application. So envision you have your 10 application pods. You could potentially run your Waypoint proxy maybe as 2 or 3. Depends on whether your Waypoint proxy is serving the service account or namespace or multiple namespace. So you can have that in mind. It provides, I guess, a lot more flexibility in this case for you to use. Yeah, and the other thing I would say, like a lot of our users actually come to us, they need Istio, some of the layer 7 just for traffic management. One good thing about Waypoint proxy is, like in my demo, I showed how you shift the traffic to 10% to version 2. So when you are happy with version 2 of your service, you could potentially remove your Waypoint proxy if you don't need any of the layer 7 functions. So that's the other thing you can keep in mind too. It could be like a short-lived Waypoint when it finishes its job. Yeah. Good question.
Thank you. I think that's all the time we have for questions. Reminder on the slide, please use the app. please vote for all the presentations you've seen today, not just Lin's. But please give another round of applause for Lin.